The global landscape of artificial intelligence is undergoing a foundational shift where the raw scale of training data no longer defines the ultimate leader. As we navigate the year 2026, the focus has moved from massive pre-training phases to the sophisticated optimization of compute resources during the inference stage. This transition marks the era of test-time compute, where models are designed to deliberate and reason through complex problems before delivering a final response. By allocating more processing power at the moment of query, we unlock a higher level of cognitive depth previously unseen in standard language models. Leading research institutions across the globe are now prioritizing these reasoning-heavy architectures to bridge the gap between simple prediction and genuine logical synthesis. The paradigm of bigger is better is being replaced by the strategic mandate of smarter is faster through the use of inference-time search algorithms. We are witnessing a technological inflection point where the ability to think before speaking defines the next generation of sovereign and industrial neural systems. Understanding this architectural evolution is critical for any leader aiming to harness the full potential of generative agents in an increasingly competitive market. In this comprehensive analysis, we will explore the scaling laws for reasoning and the implementation of reward models that guide the chain of thought. You will learn how to balance the trade-off between reasoning latency and decision accuracy to ensure your organization maintains a distinct strategic advantage. We provide a deep dive into the technical frameworks that allow AI agents to navigate uncertainty and produce high-fidelity outputs in mission-critical environments. By the end of this session, you will possess the specialized knowledge required to implement test-time compute strategies within your own digital transformation roadmap. The trajectory toward artificial general intelligence is being accelerated by these architectural shifts as documented by the Singularity Hub and the OpenAI research teams. As we analyze the current state of deep learning, it is evident that the efficiency of European large language models is gaining significant ground. The OECD AI Policy Observatory highlights the importance of global governance as these reasoning models begin to impact the labor market and decision-making. From the research labs at Baidu to the visionaries at SoftBank, the integration of robotics and multimodal AI is being driven by cognitive deliberation. NIST provides the gold standard for securing these advanced systems, ensuring that the ethical integration of reasoning-heavy agents remains a top corporate priority. The convergence of biological sciences and machine intelligence at Nature Research further underscores the necessity of models that can simulate complex human-like reasoning. Data-driven innovation culture is evolving at Splunk and Capgemini, where intelligent industry is becoming the standard for sustainable and resilient global supply chains. The Brazilian Internet Steering Committee emphasizes data sovereignty, while the EU AI Act sets the boundaries for trustworthy and transparent artificial intelligence deployments. National security and tech policy are now inextricably linked to the performance of these reasoning engines as analyzed by the experts at Just Security. The vanguard of AI is no longer just about generating text, but about the precision of the logic that powers the modern global economy. The first pillar focuses on scaling logic during inference, which allows models to explore multiple reasoning paths before selecting the most accurate path. This approach utilizes specialized search algorithms that rank potential solutions based on their logical consistency and alignment with the initial user prompt goals. By increasing the compute budget at test time, we can achieve performance gains that were previously only possible by doubling the size of training datasets. The second pillar involves the implementation of chain-of-thought reward models, which provide a feedback loop for the agent during its internal deliberation process. These reward models are trained to recognize valid logical steps and penalize hallucinations, ensuring that the final output is both factual and highly reliable. This architectural fix addresses the challenge of model drift and ensures that reasoning-heavy agents can handle complex multi-step instructions without losing critical context. The third pillar examines the critical trade-off between reasoning latency and decision accuracy, which is vital for real-time applications in high-tech manufacturing environments. Organizations must determine the optimal amount of deliberation required for each specific task to avoid unnecessary delays while maintaining the highest possible quality standards. The use of zero-trust architectures at Samsung SDS ensures that these reasoning processes remain secure and protected from adversarial attacks or unauthorized data access. The fourth pillar provides scientific proof through the application of scaling laws for reasoning-heavy agents as researched by the Vector Institute and Fraunhofer. These laws demonstrate that the return on investment for test-time compute is exponential when applied to domains such as cybersecurity and advanced scientific research. By mastering these four pillars, leaders can transition from simple digital adoption to a state of true digital resilience and sovereign technological leadership. We must also consider the role of open-source benchmarks from Hugging Face, which allow for the technical demystification of these new architectural shifts. As the Indian AI adoption story continues to scale, the focus on AI for good highlights the importance of practical governance for the entire global South. The strategic insights provided by the MIT Sloan Management Review emphasize the need for redefining business models to be AI native at the core. Digital transformation is not a destination but a continuous journey of adaptation and innovation supported by high-level data from the PwC Global Trust. The threat landscape in 2026 requires a proactive approach to cybersecurity where AI phishing and other advanced attacks are met with resilient infrastructure. Daily alerts from Cybersecurity Dive and updates from CISA provide the necessary situational awareness to protect critical assets in a rapidly changing world. The integration of these strategic frameworks will enable you to lead the global innovation era with confidence and a clear vision for success. The authority orchestrator ensures that every piece of knowledge is synthesized into a powerful tool for your personal and professional growth and development. Let us examine a practical demonstration of test-time compute in action where a model is tasked with solving a complex engineering problem. Initially, the model generates several internal hypotheses and uses a verifier to check the physical constraints and mathematical accuracy of each proposed solution. The process of deliberation is visible through the chain of thought logs, which show the model correcting its own errors before presenting the final result. This self-correction mechanism is the hallmark of advanced reasoning agents and is what sets them apart from the legacy models of the past. Notice how the allocation of extra compute seconds leads to a significant increase in the precision of the technical specifications and the safety. The user can adjust the reasoning intensity based on the complexity of the task, allowing for a customized balance of speed and deep analysis. This demonstration proves that the quality of the output is directly proportional to the amount of logical search performed during the inference stage. In a cybersecurity context, this allows for the real-time detection of zero-day vulnerabilities by simulating thousands of potential attack vectors and defensive strategies. The practical application of these technologies is already transforming the way we approach software development and the management of critical national infrastructure systems. By integrating these tools into your existing workflows, you can achieve a level of operational excellence that was previously thought to be impossible. The synthesis of these concepts reveals that the future of AI lies in the ability to manage compute resources with surgical and strategic. We have moved beyond the era of stochastic parrots toward a future where machines possess a genuine capacity for logical deduction and structured. The convergence of digital transformation and cybersecurity is anchored by the performance of these reasoning engines in every sector of the global market. Your strategy must include a robust framework for testing and validating these agents to ensure they align with both ethical and performance. The bridge to the future is built upon the foundation of continuous learning and the application of state-of-the-art research from the world. As we conclude this deep dive, remember that the most successful organizations are those that treat knowledge as their most valuable and strategic. Stay ahead of the curve by following the latest developments from the global research portfolio and implementing these insights into your daily operations. Turn knowledge into your greatest asset by applying these strategic frameworks today and lead the global innovation era. Subscribe to dominate the AI vanguard and lead the next era of innovation. Channel powered by generative AI architecture.